Science Twins, what's going on? That's Mr. Walton here. We're going to talk about double replacement reactions. And so a double replacement reaction, you should already know this a little bit from our classifying reactions. Double replacement reaction is when a compound reacts with another compound to create two totally new compounds. You can think of it as a reaction where the cations swap places with each other, or the anions swap places with each other. So double replacement reactions involve the swapping of both a cation and an anion. When predicting the products of a double replacement reaction, simply switch either the cation, remember cats are positive, right? So, or an anion. And let's take a look at another demonstration, and we'll be able to analyze this demonstration and see what exactly is going on. So I've got a reaction here, and the reaction is between sodium iodide and lead 2 nitrate. Now, let's think about this. Remember, the positive ion is going to switch with the positive ion, and metals and hydrogen most of the time are positive. Metals, ammonium, hydrogen, they're all positive if they're in a compound with something. So the sodium and the lead are going to swap places, right? It's almost like this compound here is a positive and a negative together, and they're attracted to each other, right? The sodium and the iodide are an ionic compound. They're attracted to each other. The lead and the nitrate are also attracted to each other. So in this reaction, the sodium and the lead are going to switch, and we should get sodium. Sodium's not going to be with the iodide anymore. It's going to be with the other negative ion, right? Positives like to be with negatives, so sodium and nitrate are going to be together now. And then lead 2 and iodide are going to be together. So let's see this reaction, and then we're going to come back and we're going to write it as a chemical equation. We're going to see if we can explain what we observed during the reaction. Have fun! Okay, that was an interesting reaction. So what we saw there is we added two clear, colorless liquids to each other, and as soon as they came into contact with each other, they made a yellow, cloudy mixture. Now, yellow cloudy mixture isn't scientific enough, so there's a word that we use for whenever we form a solid. That's what you saw. You saw a solid being formed. Does anybody remember what that word is? Oh, yeah, some of you got it. Precipitate. That's right. So let's go ahead and let's write out the chemical reaction. Let's see what's actually going on. Sodium iodide is an ionic compound. So sodium is +1, iodide is -1. So sodium iodide. And you saw that it was in a solution. Okay, sure. Lead 2 is 2+, nitrate is 1-, so we need 1 lead and 2 nitrates. So PbNO3 2. And again, you saw that it was a solution, so it's aqueous. We're going to get sodium nitrate. Sodium's +1, nitrate's 1-, so NaNO3. And we're going to check, I almost wrote it down. We're going to check what its state of matter is. And then we're going to come back and we'll see. Lead 2 is 2+, iodide is 1-, so PbI2. And we're also going to check its state of matter. Sorry, I'm running out of room here. So let's go ahead and check their states of matter. Let's go ahead and check their states of matter with the data booklet. So here's our data booklet. And the first one was sodium nitrate. So we'll go down to page 8. We'll take a look at the solubility table. So we look for, sodium is right here. It's a group 1 ion, so we could look there. But let's look for nitrate, NO3-. NO3- is here. Do you see sodium nitrate down here? I don't. So it's not solid. It's not going to form a precipitate. The yellow precipitate that we saw was not sodium iodide, because sodium and iodide, that combination, is soluble. So this combination is aqueous. Now let's do lead 2 iodide. We'll look for iodide here. Look down, and I do see lead 2+. Lead 2+ and iodide, whenever they're together, they will make a precipitate in water. So we write solid. So here we're going to write a solid. So that was our, this is going to look terrible. That was our yellow precipitate. Oh man. That yellow on white is never a good idea. Whatever, that's okay. So let's go back and let's analyze a few more chemical reactions for our double replacement reactions. So let's take a look. Example 1, aqueous magnesium fluoride reacts with hydrochloric acid. So, we're still yellow. Oh man, that's terrible. So magnesium fluoride reacts with hydrochloric acid. Remember, hydrochloric acid is HCl. And what's it going to produce? So remember, the positive ion is going to kick out the positive ion. Magnesium, when it's in a compound, magnesium will be positive. And the hydrogen is the positive version. The chloride is negative. So the magnesium and the hydrogen are going to swap places. So we're going to get magnesium, not magnesium acid. We're going to get magnesium with the chlorine. So chloride. And we're going to get hydrogen with fluoride. So we could say hydrogen fluoride. Another way of saying aqueous hydrogen fluoride is hydrofluoric acid. So you might see in the notes that it's labeled as hydrofluoric acid. That's all. So magnesium fluoride. Magnesium is 2+, fluoride is 1-. So we're going to go MgF2. But it's a solution. It says aqueous magnesium fluoride. Reacts with hydrochloric acid, HCl, and it's aqueous because they tell us it is. So we're going to get magnesium chloride. Magnesium's 2+, chloride is 1-, MgCl2. And let's double check the data booklet, MgCl. So when I look at Cl, Mg's not down here, so it's going to be aqueous. And then hydrogen fluoride is HF. Hydrogen's 1+, fluoride's 1-. So hydrogen fluoride, and it's going to be aqueous. All acids are aqueous as far as you're concerned right now. Okay, let's try this. So 1 magnesium, 2 fluorines, 2 fluorines, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Perfect. This is a perfectly balanced chemical reaction. Let's move on to example number 2. When aqueous lead 2 nitrate is added to aqueous sodium iodide, a yellow solid is formed. Well, we already looked at this example, right? That was the example that we just looked at. So we're going to skip past this because we wanted to start our video off with that example. So let's move on to example number 3. Aqueous calcium chloride. So calcium chloride is reacting with silver nitrate. Silver nitrate. So let's think about this. What's going to swap places? Well, the positive, right? The positive and the positive are going to swap places. So we're going to get silver chloride and calcium nitrate. And then we just have to go from names to formulas, which is always super important. Calcium, when it's in a compound, is 2 plus. Chloride is 1 minus. So calcium chloride. And it said it was a solution, right? Aqueous. Silver nitrate. Silver is plus 1. Nitrate is 1 minus. We just need 1 of each. AgNO3. And it said combined with silver nitrate. Well, okay, we're going to assume it's a solution. I should probably change that. So we're going to get silver chloride. Again, that's 1 plus and 1 minus. So silver chloride, and we'll check the data booklet for its state of matter. And calcium nitrate. Calcium's 2 plus, nitrate's 1 minus. Calcium nitrate. 2, and we'll check the state of matter. Okay, let's go in. Silver chloride. I see chloride and silver. Whoa, that is going to produce a precipitate. Absolutely, that's going to form a precipitate. So solid calcium nitrate. I see nitrate here. No calcium nitrate, so it's not solid. It must be under most. It's aqueous. I'll give you a hint. Nitrate compounds are always aqueous. There is nothing that forms a precipitate, as far as you're concerned, nothing that forms a precipitate with nitrate. So, and whenever you see nitrate, it's always going to be aqueous. So, let's go ahead and balance this chemical reaction. 1 calcium, 2 chlorines. We need 2 chlorines, 2 silvers. We need 2 silvers. 2 nitrates. We have 2 nitrates. This is a perfectly balanced chemical reaction. Nice. Good job. So now we've got some examples here. Balance these chemical reactions. Do it and check the notes for the key. And then we've got some things here where do these double replacement reactions. I want to be very clear though. Anytime you've got a base reacting with an acid, remember a base is an ionic, so it has to be metal, non-metal, right? So this is an ionic hydroxide. It's ionic, so metal with a hydroxide. Anytime you see a metal with a hydroxide reacting with an acid here, right? The sodium and the hydrogen are going to swap places. When they do, you're going to get H with the OH. So just write it as H with the OH. That's water, right? So that's 100% that's water. And I think it comes up a couple times in the balancing here. Yeah, it comes up once. where I've already written it as water, but HOH, okay? Right? H2O is really H bonded to an O bonded to another H. So we could write it as HOH. That's fine too. Just happens to be that there's two H's and one O in this. So it's way easier. This hydrogen in green comes from here. The hydroxide in purple comes from here. So treat the beginning hydrogens as if they're separate from the hydroxides. That's just a little tip for balancing those reactions. So anytime you have an ionic hydroxide reacting with an acid, right, the H is going to kick out the K and you're going to get HOH. Just leave it as HOH, right? It's going to help you if you just leave it as HOH, okay? But that's only when you have an acid and a base. Try these reactions out, okay? We did a couple of them. Try these reactions. Check your answers against the key. Let us know if you have any questions in the office hours. Office hours are 10:45 to 11:15 a.m. every single day. I haven't had a lot of people come talk to me during office hours, and I would love to hear your voices or see your beautiful faces or something like that, because I'm getting bored. I'm not going to lie. Okay, let me know if you have any questions. Otherwise, have fun. See you later.